Hello, everyone. Let me show you something interesting today. I will enter a number in one process and without directly sending it, another completely separate process will use that number and generate the multiplication table. No function call, no shared variables, just a file. Let's see how this works. Normally, processes do not share memory. Each process lives its own isolated world. So the question is, how can one process pass data to another? The answer is surprisingly simple. We would be using a file as a communication bridge. Imagine this scenario. Let us say I write a number in our classroom board. Later, I am asking some of you to read that number and solve the problem. Now, I'm not going to interact with you directly, but the problem statement written on the board connected them together. That board is our file. So here is what we'll be implementing. We'll be having parent process which writes a number into a file, and there would be a child process which reads the number and generates the multiplication table. So one can say that we are building a producer-consumer style interaction using a file. Let's now bring this idea to life using a C program on Ubuntu. Now here, like as usual, so let me start the code, typing the code. So file sharing IPC.c. So as usual, you would be seeing that like I will be including some set of files. Okay. So hash include stdio.h unistd.h. Okay. Then stdlib.h. Then sys slash type.h. Let us see now how this works. Fine. Okay. So now we have included the files, necessary files that we are intending to use. So integer main, printf, program execution started. Then we'll create a process, child process we want to create. That's why we'll be writing this fork. Fine. Now, what we want is we want to write the code for the parent process. If PID greater than 0, this would be our parent process. Correct. So what can consider this? So now I'm going to create a file. Okay, and I'm going to write that content into that file. So file star fp equal to fopen. Now this is my data.txt. Say I'm using this file, okay, and I'm creating it with the right permission. If fp is equal to null, always we do check if there is a problem in creating a file or opening a file. So printf error opening a file slash. Good. So then like if it happens, then we are going to make use of exit one. I will explain why I wrote exit one later. Fine. Now this is done. Now let us consider like in the same code, like once the file is opened, we want to read the data, okay, through scanf, and we want to write that number into this file. Correct. So integer number printf. Let us say we are saying I am a parent process with PID is equal to %d. Get PID. Okay, complete. Here, so we got this. Now we have to read the number. So printf enter number to share with child process. Scanf %d ampersand number. Correct. So we are reading that data. Now we will be adding this printf bracket parent process writing the number in the file. Correct. Slash n semicolon. Then using a printf, we'll write this number there in the file. So fp %d, correct, and then the number that we intend to write in the file. Now, once it is done, let us close the file. Fclose. Fp. This is from parent, correct? Now, parent should indicate I have done. I have completely written the data. Parent data successfully return the file. Action. Correct. Now this is code for our parent process. That's where we started. Correct. Right. So this is our parent process code. Right. Now, else if PID equal to 0, that means this is a child process now. What is to be done? We have to read that data from the file. Correct. So let us write if PID equal to 0, printf I am a child process with PID %d /n and then get PID. So we will write here and waiting for the data, because child is supposed to wait for the parent. Correct. So I did everything correctly. I typed everything correctly. Yes. Correct. Now we'll take a pause here, like saying sleep for 5 seconds. We'll give time for the parent process to read the data. Now let me define in the child again. So we'll copy the statement above. We'll try to find out like if there are errors. So we'll now read the data, read it. Correct. Instead of earlier we wrote what? Write. Correct. Now in this case we'll read it. So this is a local variable to that local scope. Correct. So if fp equal to null, then I will use the same code here without wasting our time. Correct. Yes. Now, once this is done, like we have to read the number and process it. Correct. So we are declaring in this scope fscanf fp. Now what we want to read from file. Correct. Double quotes. What is to be read? %d, and as we are using fscanf, so number. I will use number here the way that I used earlier. Correct? Bracket complete because it is a fscanf. Now here printf child process got %d. Correct? And we want to print that. So I'm saying what value I got from the file. Correct. Now, once it is done, what we have to do is we have to print the multiplication table. So for I equal to 0, sorry, 1, we have to write integer I equal to 1. I less than equal to 10, I plus plus. Now we are just reading that data. We are not currently writing into the file directly. Okay, we'll see later if at all that this code is to be modified, then what to, because we are reading that data. We are seeing that data and we are solving that problem. Correct? So printf will print it here. Fashion %d multiplied by %d equal to %d. Correct? And add slash n towards end instead of this. Otherwise, it will take more than one line. So correct. So we got this. Then what is to be printed? First number multiplied by I multiplied by number I. Correct? So number, then I, then number multiplied by I. This would be printed on every line. Correct? We are done with for loop. Then now we have to close the file. F close, FP. Fine. Then you say printf. The task child was supposed to complete. It's done. Completed the task. Child with PID %d completed the task. Slash n get PID. Fine. Then this our bracket is complete. Then return 0. Then done. So let us save this code. I will explain it again. Okay. So what we did was we declared, we created a child, correct? And from parent, we are reading the, we are opening a file, mydata.txt in write mode. If it is not there, automatically it would be created. Fine. So then we are reading a number in the parent process. We are writing that into the file by using a printf, correct? And then we close the file. Then in child process, it reads that data and then operates onto it using for loop. Let us compile this code. Dash M32. Okay, let us correct the errors. So my typing errors, typing mistakes. seeing the wrong line. Yeah, in child, I think I made a mistake here by including double time double. Save this. Let us compile. Sorry. So we are done. Correct. So let us compile. That was my typo mistake. Typo. So let me open another terminal so as to see what is happening. So just I'm showing you now how processes are created. So I will write ps dash. Okay, once this code runs, you can see a dot out, a dot out. Now I have child process created. Now as I haven't given any number, so it completed the task. Correct? Like you can see. So let me execute one more time. You could see that there were two. So I am saying 4. Correct. So let us check the file. Yeah. So one can see that multiplication is written here. So it is reading. So if I check the file ls dash ltr, open this file, my data dot txt. So it contains 4. So let me remove that file. Now we don't have any file there. Correct. Let me execute the code again. Let me write 6. Now child, because it is waiting, so parent terminated. Child executed it, but you can see now the multiplication table is written. Now let us understand what exactly happened here. Correct. So once I compiled, I entered the number 4 earlier, then 6. Now watch closely. What happened here? The child process acted upon it. Like when I executed, correct. When I input 6, so child parent did it work. Child was reading, and now child process worked on it, and then it completed the execution what it was intended. Now if I go back to my code, let me explain you what I wrote. So when if I see this code, what fork was supposed to do? Fork was supposed to create the process, correct? So what exactly we did? This fork above, like fork system called above that we used here, it created a new process. From here, two independent executions begin. One becomes parent, other becomes child. So this is the parent code that we wrote. The parent opens the file in write mode, correct? If the file doesn't exist, then it gets automatically created. And if it exists, it gets overwritten. We will see that. Okay. Now the parent takes the input, and this is the data we want to share. Which one was that? This one. We want to share this data. Correct. Then comes the key operation, fprintf. Like it has written that data into file. So this line stores the data into the file, and the file becomes the communication medium. Correct. Now here the child process starts, but it waits because it should make sure that parent has written. Now suppose child gets created, and due to some reason file cannot be created, or to ensure that file already contains the data. If it doesn't contain, then it should wait. That's why we address sleep file. Then the child opens the same file in read mode. That has happened. This is the same file which was written by the parent. You can see the title, correct, or name of the file. Then we wrote fscanf, correct, below here. So this was meant for to read the number from the child process. So no direct communication, only file access. Now comes the transformation here. Okay, so we wrote for loop for multiple. This loop generates numbers from 1 to 10 for I equal to 1 to I less than equal to 10. And for each iteration, we calculate and print the multiplication. And this turns a single number into the structured output that we got on the screen. So when we print process IDs, we confirm that two different processes executed the program. You can check it here. Like what are the processes that we got? We got process ID as 17448 for parent and 17449 for child. Correct? We confirm that these two different processes executed this program. Let us observe here a full flow. Parent creates the data, file stores the data, child reads the data, child processes the data. No direct interaction, only file is used for communication purposes. Now suppose, what if child tries to read before parent writes? The file may be empty. So let me show you, okay, how it works. Okay. Now let me execute. Issue. Execute dot slash dot out. Now suppose if I don't write the data. So ultimately, what are the file that got created? Correct. If I go and check it here, the file dash LTR. You can see size of that file because with the data was not written. So the file may be empty or incorrect. That's what is happened. And that's why this coordination between two files is important. And as coordination could not happen, it took some garbage value there for that variable. It assumed. Right? In real system, this method is used when data needs to persist. Processes run at different times and simple communication is enough. And what are the program that we saw? Like if I execute this code again, if I give number, now you can check it here. Like if I go and check here, the size is changed for the file. And this example shows that even a simple file can act as a power communication bridge between processes. Processes may be isolated, but the right medium connects them. And that's how the inter-process communication can be implemented through the file. Thank you very much.